Now we are taking up the new topic, that is the element, compound and mixture. And before we start, we need to know these terms separately, what actually these terms are and what subcategories constitute them. Or so we are starting with the first term, that is element, right? So what do we mean by element? You must be familiar that till date 124 elements are already being discovered. Within in periodic classification, I told you that there are 124 elements that are still discovered. The number can be wrong also, because the number is increasing day by day. There are many discoveries, many elements that are whose discoveries are actually in a pipeline. So this discovery number goes on increasing as the days are going on. The number of discoveries are increasing and we get to have many new elements. But in certain books you will get the number 118, you will get the number 124, you will get the number 128, and even you may get the number 132, because every day the new discoveries are being carried out by our scientists, and we have already discovered so many elements in the lab by just making them you can say synthetically made. So therefore the number, I cannot tell you the correct number, because you know that discoveries are still going on. So we'll just focus on the element, what actually the element is. So element is a substance that can't be broken down into more simple substance, right? Now first of all, you should be familiar with this term. That means element is a substance, a kind of substance which is in the simpler form, right? You cannot make more simpler form out of it, right? So element is a substance which can't be broken down into more simple substance. Now the question must be striking in your mind that why this element can't be broken down into a more simpler substance. The reason being that element is made up of atoms. And you know, the atoms are the smallest particles, right? We do have the subatomic particles, but when we are talking about the element, compound and mixture, we talk only till the atom, because those subatomic particles are getting changed. But whenever we are talking about the element, we will be taking into the consideration only the atoms, not the subatomic particles, right? So element is a substance which can't be broken down into the more simpler substance. The reason being that it is made up of atoms, and we know the atoms are tiny, very tiny subatomic, very tiny smallest particles which which do not exist in nature independently, right? But we do have certain atoms which exist in nature independently, like we talk for the noble gases. We'll be doing it you'll be more and more, we'll be taking up the element, you'll get to know, right? So as for now, you should know that element is a substance, can't be broken down into more simpler substance. The reason being it is made up of atom, and atom is the smallest particle of the matter, right? So this is the element. Now when we talk about the atom possess the property of atomicity. What do we mean by the atomicity? Atomicity actually means the number or the kind of atoms present, because if you take into account oxygen, so oxygen do not occur in nature as O, it occur in nature as O2, because at room temperature the state which is stable is a gaseous state, and in gaseous state it is formed by the combination of two atoms which actually combine to form a molecule. So that means the atomicity of oxygen is 2. We'll say that as it contains the 2 number of atoms, so that means it is diatomic. Similarly, if I take into account an example of sodium, we know the symbol of sodium is Na, derived from its Latin name natrium, right? So how sodium exists in nature, do you have some idea? So yeah, sodium exists in nature as Na. It does not form molecule at room temperature whenever we see sodium, or when we look for the existence of sodium, it occurs in nature as Na. So that means one atom can individually exist, therefore it is called as monoatomic. That means though it is formed of many atoms, but still it exists as not as molecule but as an elemental form, so it is monatomic. So likewise we can have the triatomic molecule. That means if it consists of three kind of atoms, even it can be kind, it can be number also. Like if I take into the this thing, like if I take an example SO2. So how many atoms you get to see? See, there is one sulfur atom and two oxygen atom. 2 plus 1 comes out to be 3. So that means in this molecule, obviously it is a molecule because it is comprised of two different atoms, right? So how many atoms is forming in this molecule? 3 atoms. So that means it is said to be triatomic. So similarly we have monatomic, diatomic, triatomic, and for above we generally use the word polyatomic. You must be thinking that do we have any element which exists in which many atoms combine to form a molecule? So I want to answer you this, that there are few atoms or any elements or a molecule you can say which is formed by the combination of many atoms. Like sulfur exists in nature in an octatomic form, that is 8 atoms combined to form one molecule. Similarly, if we talk about phosphorus, phosphorus exists in nature as P4. So this atomicity do not depend on any hard and fire rule, it just depends upon how the element is existing in nature. Is it existing in an elemental form or is it is existing in a molecular form? And if it is existing in a molecular form, so how many atoms are combining to form that molecule? So this is, I have told you that the atomicity can be monatomic, one atom, it can be diatomic, triatomic, polyatomic, it can be any of these. It is not any strict rule that it is found only in such and such form. Yeah, we get sulfur only in a restricted form, that is S8, but it is not compulsory that the element which resembles the sulfur should occur in an octatomic form. It can be in it can be diatomic, can be triatomic, right? So this is the atomicity of the element, or you can say the atomicity of the molecule, that how they exist in nature. Now taking into the consideration what is the nature of the elements. Nature, here I don't refer to acidic, basic, neutral or amphoteric nature. It means the nature here in this topic actually means the types of elements, like depending upon the properties, how elements have been classified. So you should know that elements are classified actually into the 4 categories. One is metals, other is non-metals, next is metalloids, and we do have the 4th one, that is inert gases, also called as noble gases. So elements have been classified into the 4 categories, that is metals, non-metals, metalloids and noble gases. Now, what is the criteria behind of classifying the elements into the 4 categories? The criteria is only the properties, the physical and the chemical properties they are actually showing. That is how they conduct electricity, do they produce heat, or you can if current is passed, what happens, the heat is produced or not, are they sonorous or are they lustrous. So these are certain properties, physical as well as chemical, which is required to classify the element into any subgroup, right? So we'll be taking up the different properties, because we should know that if I say sodium is a metal, so you should know that why it is considered to be a metal, what are the specific properties it is showing that it is behaving as a metal, and not only the metal, it is a reactive metal. So what actually the properties are, and what kind of exceptions we get to see, like if some element is coming under the class of metals, but still it show a certain kind of difference. So what are those metals which are actually showing some exceptional behavior when they are compared with the rest of the metals, and what is the basic difference, that why they are still kept in the same category. So we are taking up the difference just to know that what actually the properties are and what actually you can say they are showing in the properties, right? So we are just taking up the metals and the non-metals, right, in detail, just to differentiate between them, so that you should know in a better way what actually the properties are exhibited by metals and non-metals. So I am just considering the metals and the non-metals first. We will be taking metalloids and the noble gases after. We will be doing this metals and non-metals difference in the characteristics, right? So metals are actually malleable. Non-metals are non-malleable. Now the question comes that what do we mean by malleable and non-malleable? You must not be familiar with this term malleable, because in general routine we don't use this word malleable. So just keep in mind this malleable comes from the property malleability. What is that? Malleability is actually a property of converting any metal into thin sheets. So malleability refers to the property by which we can beat metal into thin sheets. And how we can do it? We can do it by hammering it, right? So malleability means, again I am repeating the definition because you need to know this definition. So start using this word. See, if any time you come across a new word, start using in a daily routine. Once you will use it, you will have a command over that word, right? So what do you mean by malleability? It is a process of beating metal into thin sheets by hammering, right? So as is according to the property, we have seen that metals can be beaten into that thin sheets and non-metals cannot be beaten into that thin sheets. And the second property is metals are ductile and non-metals are non-ductile. Again, it is a new term for you. So how many of you actually know what actually the ductility or the word ductile means? I think there will be only few of the students who will be familiar with this term ductility, because this is again a term which is not being used in a daily routine. So just start using the new words, because we want to increase your level. So as your class is increasing, you need to increase your level as well. So start using these new terms so that your standard is just raised, okay? So coming to the point, what do we mean by ductility? It means drawing metal or any substance. It is not particularly metal, because ductility is a property refers to when that means beating a substance into thin wires, again by hammering. So when any substance can be beaten into thin wires by hammering is said to be ductile, and when any substance cannot be beaten into thin wires by hammering is called as non-ductile. And as far as the property is concerned, we have seen metals are ductile. That means they can be beaten into, I have used the wrong word. You are not going to use this word beat. Beat is used when you are drawing the metal into thin sheets. But when you are converting the metal or any substance into wire, just use the word that ductility refers to you can say drawing the metal into or any substance into thin wires. Use the word drawing instead of beating, okay? And so ductility refers to, again I am repeating a definition for you. Ductility means drawing any substance into thin wires, right? So metals are ductile and non-metals are non-ductile. Now the question must be striking that what actually the difference is, that it can be beaten into thin sheets or wires, but the non-metals can't be beaten or drawn into wires. So the reason being that when we hammer them, they are brittle. So what happens that when we hammer them, they break. So when they break, so how come we can form thin sheets or wires or draw wires out of them, right? So the reason being because they are brittle, so that is why they are non-malleable and they are non-ductile, right? The third property comes as they are good conductor of heat and electricity. And if we compare non-metals with metals, they are actually poor conductor of heat and electricity. The reason being, now just keep in mind, for any substance to be a good conductor of electricity, you can say the property which it should possess to be a good conductor is that it should have free mobile electrons. free mobile means they can move, okay, free mobile electrons. If any substance fulfill this property, that means any substance has that free mobile electrons, then only it is capable of passing electric current through it, otherwise it won't. And as we know that the metals actually have many electrons, that is why they donate electrons, and and when we are talking about non-metals, they are deprived of electrons, they need electrons. So that means there are extra mobile electrons in case of metals, and those electrons are not present in non-metals because they are actually deprived of that those electrons. They are electron acceptors. So that means there are free mobile electrons in metals, and there are no free mobile electrons in non-metals. So that means which the presence or absence make them the good conductor or the poor conductor of electricity, right? And as far as the heat is concerned, there are, you can say, the two applications of electricity, that is the magnetism. You will be doing in this higher standard that whenever the current passes through any substance, it leads to production of two phenomena. One is the production of heat and other is the production of magnetism. That means the current can give rise to magnetism, and current can give rise to the heating effect as well. So any substance which allow current to pass through, that means it will obviously it is going to produce heat also, and any substance which do not allow the electricity to pass through it, then how come the heat will be produced? So similarly, the metals are good conductor of heat and electricity, and non-metals are poor conductor of heat and electricity. The next property which is striking my mind, that is metals are lustrous. You must have come across many metals in daily routine. So what do you see? That they have a spark, they shine actually. So they are lustrous. But when we talk about non-metals, they are non-lustrous. They do not emit such shine. And the other property which you might have noticed, that if you hit the metal with anything, suppose you are sitting on a bench, right? You have you have a wooden table, and there are the rods, the iron rods which are going down. Just you can say hit that rod with your pencil or a marker or anything what you have in mind. You will see it will produce sound. You can hear a different kind of sound. So that means metals are sonorous. That means when you hit the metal, they produce sound. So that means they are sonorous, right? They exhibit the property of sonority. And when we talk about non-metals, they are non-sonorous. They do not produce any kind of such sound. So that means they are non-sonorous, right? The next property we are taking into the consideration, that how they exist. So we have seen that metals usually exist in a solid state, generally, right? And the non-metal exist in any three kind of state. They can be solid, they can be liquid, they can be gas, right? And if they are solid, that means the particles are tightly packed. So obviously it is going to be hard. So that means metals are, I will use the red pen, so that you should be not get confused, because we'll be taking up the exceptions also later on, and that we'll be writing with a different pen, so that you can easily recall those exceptions, and those exceptions are very important, and most of the time you get the questions out of it. Okay, so they exist in solid state. Solid state means particles are closely packed, so that means they are hard. Right, and they exist in solid, liquid and gas, so that means there exists a different type of arrangement. As we know, the particles are closer in solids, far apart in liquid, and very, very far apart in case of gases. So likewise, you can say the hardness or the softness, or you can say the strength of forces change. So we can say they are actually not so hard, so I am writing that they are soft, they are not so hard enough, right? The next property, obviously the particles are closer to each other, so that means it indicates they have high density. Compared to it, they have low density, means low mass per unit volume. That means mass per unit volume is density. So that means they have low density. Again, they are harder, so that means they have high melting and boiling point. That means because they are solid, particles are closely packed, so that means much heat is needed to boil or to melt them, as the force of attraction might be very strong because they are existing as solids. And if I talk about non-metals, their melting and boiling point is comparatively low melting and low boiling point, right? And moreover, one more thing, that they have high tensile strength, and compared to it they have very low tensile strength. The question must be striking in your mind that what is actually a tensile strength. So because you'll get to see this term in various books, but no teacher is actually, there is no perfect definition for it. Sometimes the students are asking from the teacher and they just manipulate them with it is just a simple term. Tensile strength, you can say, is actually how much rough and tough it is, right? So we know that we can handle metal, it is rough and tough, means it can be handled, it do not get break easily, or it is, you can say the rough and tough, you are, I think, familiar with this term, rough and tough. So similarly we can say they have high tensile strength, means great force of attraction, so you can handle it in any way, it is not going to break easily, right? And when we talk about non-metals, it has low tensile strength because existing as solid, liquid and gases in different states, the force of attraction is not so strong, so it might break also. So that means they have low tensile strength, right? So these are the properties under which we can classify the metals and non-metals. But we do have the exceptions that exist in metals and non-metals, and we need to know those exceptions because they are very important. The question which you will be getting will be maximum out of the exceptions only. So just look at the board, I am writing you the exceptions. So just recall in that mind, there is not any reason behind that why it is not this or that. It is just the exception, it is just a behavior that yeah, this element is included in this category, but it is not showing this specific property, or the reason behind that, yeah, it is not existing as liquid or gas, like that. So just look at the board. We have a non-malleable metal and non-ductile metal. Example is zinc. It is non-malleable and non-ductile. And when we talk about the best malleable and ductile metal, that is silver. So silver is the best one, the star I am using is for the best one. So silver is the best one and zinc is the non-malleable or non-ductile, can't be beaten into thin sheets, or you can say can't be drawn into wires, right? Next we are taking up the good conductor of heat and electricity. As we know, all metals are good conductor of heat and electricity, but still there exists a exception, that is the tungsten. I will be writing the exceptions with the blue one. The symbol for the tungsten is W, right? So tungsten is an element, is a metal which is not actually a good conductor of heat and electricity, it is poor conductor of heat and electricity. You need to remember this exception, okay? And coming to the solid state, we have metals which exist in liquid state, that is mercury, written by symbol Hg, and gallium. They exist in liquid form at room temperature. And when we talk about the hardness, all metals are hard, but we have few metals, and you will be surprised to know that those metals can be easily cut with the help of knife that you use at home. And which are those metals? They are sodium and potassium. They are so soft that they can be cut with knife easily. Right, so all those have high density, high melting points. Obviously, if anything is existing in a liquid state, so obviously the density is going to matter, and obviously the hardness is going to matter. So these are the few examples I have told you. Just remember them carefully, that because I am again telling you the exceptions are very important. Right. Now coming to the non-metal part, we do have exception in them also. They are non-malleable, non-ductile, no exception for it. They are poor conductor of heat and electricity, but still we have a non-metal which is good conductor of electricity, that is a graphite. Graphite is an allotrope of carbon, but because it is formed of carbon, so we will be considering the form of carbon because carbon is an element. So carbon existing as graphite is a good conductor of electricity. And obviously we know any substance which occurs as a good conductor of electricity is obviously a good conductor of heat as well. And when we are talking about the next property, non-lustrous. So non-metals exhibit the property of non-lustrous, but out of them iodine and graphite are somehow lustrous. So there exists an exception that iodine emits certain kind of luster, and this in the same way graphite do. And when we talk about solid, liquid and gas, there are many non-metals which exist as solid. For example, I am writing the example for it. It is not an exception, it is an example to it, right. So in solid state we have many elements which occur like carbon, sulfur, phosphorus and silicon. And in gaseous form also we have many elements like hydrogen, nitrogen, oxygen and so on. But there the important part which you need to remember is that there is only one liquid, only one non-metal that exists as liquid, and that is the bromine. Right. All non-metals are soft. Coming to the next property, all non-metals are soft, but exception is there that the diamond, which is again an allotrope of carbon, is the hardest known substance. So it belongs to a category of non-metal, but still it is the hardest substance. And similarly, this low density, low melting point varies with the states and all. So you need to remember these, the difference. So whenever you get any element, you need to classify it. Just look for the difference that is the metal and non-metal exhibit, and likewise you can just categorize that, yeah, it is a metal and it is a non-metal. So it is the two subcategories we have discussed so far. That is, the element exists in 4 categories. We know 2 categories are still left, and those 2 categories are the metalloids and the noble gases. Right. So what do you mean by the term metalloids? I think you are familiar with this term. You must have heard before also that what do you mean by metalloid? So metalloid is that element, you need to specify that it is an element, right. The metalloid is a such form of element which actually has the property of metals and as well as the property of non-metals. Now the question must be arising in your mind, how can the element has the properties of metals and non-metals? So I just want to clear that they don't actually exhibit all properties of metals or all property of non-metals. Their few properties resemble with metals and few properties resemble with non-metals. Or we can say they show a midway between the metals and the non-metals. So they are actually placed in the D block in the periodic table. They are placed in the D block, as the metals are placed in the S block and non-metals are placed in the B block. Similarly, the metalloids occupy the D block. I think you remember that from group 3 to 12, it is the basic metalloids which are present. So, but still I'll be listing few examples for you. So we have germanium, arsenic, I think you are familiar with the symbol as well, antimony, bismuth and many more. So they are all metalloids. They resemble metals also in properties, and also they resemble the non-metals also in few properties. The 4th subgroup we are left with is inert gases. This we have already, you must be knowing it because we did in atomic structure what actually the inert gases are. Inert gases show us a special property, that is they have stable noble gas configuration. That is why they are also called as noble gases, because their octet is entirely complete, and in case of helium it is duplet. So you can say in case of helium duplet, and in case of the rest of the members octet is fully filled. They don't need to combine with certain elements. So that is why their valency is 0 and they are called as inert gases. And I am just listing an example from you, helium, neon, argon, krypton, xenon. So likewise we have noble gases. So but you will be doing in the higher classes, as we know the noble gases do not combine because their octet is complete, but still we find certain compounds of one of the noble gas, that is this thing xenon. Xenon fluorides exist in nature, and it shows many 2-3 types of fluorides, XeF2, XeF4, XeOF2, XeOF4. So that means under certain conditions the xenon combine to form fluorides, but the reason we will be taking up in the higher standard. But as far as your level is concerned, because So you need to know that what actually the inert gases are and how they can be summed up and what is the specific property. So the specific property they have is the stable noble gas configuration, as their octet or duplet in case of helium is complete, and the other thing is that they are almost non-reactive, because any element need to react to some other element just to attain the stability by completing its octet, and their octet is already completed. So that is why the inert gases are summed up like this, and they have the special property like this. So I think you are familiar with the element, with metal, non-metal, metalloid and inert gas. So these are the 4 subgroups in which the element can be classified.